Okay, in this video, I want to talk about representations for multiplication and division. In the previous video, we talked about how to decide whether or not a story problem wanted us to multiply or divide. We talked about making sure that our kids were thinking in the mind frame of being a detective and searching through the story problem for clues and trying to figure out what clues can we find to help me know what operation to do. But in this video, we're taking it a step further and we're going to actually go through each type of representation for both multiplication and division. Now, the reason why we use representations is because, okay, let's say you're looking through a word problem and you have an idea about what operation you want to do, but you're not sure if it's the right one or not. Or maybe you're pretty sure that you think, it's multiplication or it's division, but this just gives your child a way to have a visual of what they're thinking. Once you can see it visually, you can sort of tell whether or not you're on the right track, okay? I know that growing up, we did not have representations. We didn't use them. Our teachers would tell us to show our work, or maybe we use keywords, but we want to stay away from keywords, as I talked about in the last video. For example, the word each. I was told that if I saw the word each, that I should multiply. Well, we saw in the last video that some of the word problems have each in both the multiplication and the division problems. So we need to be able to equip our children with strategies to help them figure out if they're on the right track or not. Help them really digest what's going on in the problem. And we're going to talk more about that in the next video whenever I discuss strategies for story problem strategies. Okay, so let's get started with multiplication and equal groups. For the purposes of these representations, we're going to be looking at 3 times 5 equals 15. Now, I'll just say it, and our representations always match our story problems. So that's super important because we know with the commutative property, you can say 3 times 5 is 15, or you can say 5 times 3 is 15. But in this case, we want our representations to match exactly what the story problem says. So let's just say Miss G has 3 students that she wants to give cupcakes to, and she wants to give each student 5 cupcakes. How many cupcakes did she have? Well, we already know that 3 times 5 is 15, but that's because we already know our multiplication tables. But how about our 8-year-olds that don't know their multiplication tables yet? So with equal groups, you simply draw 3 groups, and the 3 groups are going to represent your children, your students in this problem. And so inside the equal groups, we're going to draw tallies. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then if I don't know my multiplication tables, now I can count all these up and I'm going to get my answer. But since we are just representing at this point, we're going to go ahead and draw a question mark. We don't know the answer yet. Okay, let's move on to equations. So an equation is when you simply write the equation as I wrote it above. 3 times 5 is equal to, we don't know. Now, this is a perfect way to represent the problem, and it's perfectly fine, but this is a little more advanced if you've already, for example, done your equal groups. Because now I can look at my equal groups and say 3 groups of 5. So when we read this problem, we say 3 groups of 5. And every time your child solves a problem, you want them to be saying, it out loud, 3 groups of 5, because your representation has to match that. So we're going to just notate that the first factor in this problem is our group amount, or our group number of groups. We have 3 students, or 3 groups. And then our second factor is going to represent our group size. How many cupcakes is Miss G going to pass out to each student? So inside each group, there are 5 cupcakes. And then finally, we have our total, which we call our product. In multiplication. So that's how we do an equation, and I think that that's the closest to what we probably learned growing up. So let's move on to repeated addition. If we have our equal groups drawn, then we will see that we're going to add 3 groups of 5. So 5 plus 5 plus 5 is equal to something. So you will see that every representation has to have a question mark because we have not solved it yet. Now I drew a line between the top strategies up here, equal groups, equation, and repeated addition, because I felt like those were the ones that we would probably be most familiar with, or those are also the ones that I feel like the kids will maybe pick up the fastest or be able to help them with story problems. The ones below, I think that you will have to be a little more familiar with it to be able to use these to solve. So an array. Whenever we say array, we say equal groups, equal rows, and equal columns. It has to have all 3 in order for it to be an array. If you're a parent and your kid is in my class, one of my classes, then just go to them and say, ready, array, and they will show you a whole hand movement and motions that goes with that. Okay, so for an array, you go back to your equation, and remember, we say 3 groups of 5. So for an array, I'm going to say 3 rows of 5 columns, or 3 rows and 5 columns. Or I could say 3 rows of 5 objects. So in this case, I have 3 rows. I draw my rows first because the rows go horizontally. And then I draw my columns, 1, 2, 3, 4, 5, and then I just fill them in. So these are our rows going this way. This is row 1, row 2, row 3. I know that's kind of confusing when you're looking at the arrow. And then these are our columns. 1, 2, 3, 4, 5 columns. This is a column and this is a row. Okay, that can be confusing, but we just have to practice it. So let's move on to our strip diagram. Strip diagram is definitely something that I had never heard of before, but it's one of my favorite. So with the strip diagram, your total goes on the top, and you can, in this problem, we don't know the total because it's multiplication. So we're going to go ahead and put a question mark at the top because we don't know our total. We don't know how many cupcakes Miss G had yet. Now, if we think about our equation, 3 groups of 5, then I know I need to split this bottom section into 3 groups. So there's my 3 groups, 1, 2, 3. And then inside, I need to put 5 cupcakes in each one. Okay, So your top will represent your total, and you will be able to look at your strip diagram or your representation and see that, okay, I need to have 3 groups of 5. This is why it's so important for our kids to get used to saying 3 groups of 5 or however many groups of whatever whenever they're reading the equations, because when they draw these representations, they need to know what number goes first and second. So now I'm going to do the number line. Okay, so for our number line, we don't know our total, but we do know that we need to say 3 jumps of 5. So in this case, we're going to start at 0. We're going to jump once. We're going to jump again. And we're going to jump again. That's 3 jumps. And each time, we're going to go up 5. So this one is kind of a difficult one because I'm trying to figure out if I should put a question mark or if I should put the actual numbers here. But let's say that's where I'm going to put the question mark. And then up at the top, how many jumps did I do? 1, 2, 3. So that was 3 jumps of 5. Okay, let's move on to division. For division, with our equal groups, remember, we can just kind of look at it and know, because we know our multiplication facts, we would know how many goes in each group. But for our kiddos, they don't know yet. So what you can do is, let's say if we're thinking about the same problem, but in this case we know, let's say that Miss G has 15 cupcakes, so I'm just going to draw 15 cupcakes. And then what I need to do is I need to circle or subtract them out to each student. Now we know that each student is going to get 5 because we know that 15 divided by 3 is 5. So I'm going to go ahead and circle 1, 2, 3. So 3 groups of 5. Now, if I was doing this in person, what I would do is I would put all my cupcakes together and then I would pass them out like cards to each person. 1, 2, 3, and just keep going until I run all out of cupcakes. And then I would be able to see how many each student got. But in this case, I can't really draw that. Okay, for the equation, let's go ahead and write our equation. We have 15 divided by 3 is equal to question mark. So in this case, our 15 is going to represent the total. And then we're going to divide it into 3 equal groups. So this is our number of groups, our 3 students. And then finally, we're going to see what is our group size. How many did each kid get? Okay. So we need to keep this in mind and be careful because they could ask you in division for the number of groups or the group size. So it just depends on which one they give you and which one they're asking for. Now, repeated subtraction. This is the one that everybody's been asking about. What is repeated subtraction? Well, it's the opposite of repeated addition. So in this case, we're going to start with 15 and subtract 1 group of 5. 15 minus 5 is equal to 10. Now I have 10 cupcakes. because I gave 5 away to the first student. Now I'm going to subtract another 5 cupcakes because I'm going to give 5 cupcakes to the second student. And then I'm going to have 5 cupcakes left. Now I'm going to do it again. I have 5 cupcakes left, and I'm going to subtract my last 5 and give them to my last student, and I will have no cupcakes left. So that's what division is. You're subtracting out equal groups until you have none left. And so then you're going to go back and count how many times did I subtract. In this case, you subtracted 3 times. Now, for our strip diagram, it's kind of just backwards from the multiplication strip diagram. So in division, we already know our total. So let's go ahead and put our total at the top. Miss G has 15 cupcakes. And then I know that I'm giving them to 3 students, so I'm still going to separate the bottom into 3 equal groups. But the only difference is where my question mark goes. In this case, I don't know how many each kid gets. So that's why my question mark goes at the bottom this time. As for the number line, this is not my favorite one for division. I'm going to be honest. I prefer the other methods for division. I really like the equal groups, and I really like the strip diagram. But let's go ahead and go through it. So in this case, we know that we are starting with 15. And then I'm going to repeatedly subtract 5. Until I run out of cupcakes. Now, how many times did I subtract? Well, 1, 2, 3. And let me just mark in here that I subtracted. I want to mark that I subtracted 5, but I'm going to say I subtracted, I don't know, because that's what you're supposed to be representing, is what you don't know. But in order to make these numbers down here, you will obviously know what you're subtracting. That's why I don't really like this. I don't really like this one for figuring it out. So instead of, it's just like the number line going forward, but we're doing the opposite. This time we're jumping backward or subtracting from the total. So we're subtracting, or we're jumping backwards 3 jumps of 5. Okay, so we want to try our best to use this vocabulary and encourage our kids to go through one of these representations, or they could draw a totally different picture, but we just want to see, what are they thinking? We want to be able to tell that they understand why they're solving the problem the way they're solving it. Because technically, if you were to write on your homework that this problem, for example, was 5 times 3 equals 15, well, I would give you the points for getting the answer right, but I would mark that wrong because you don't have 5 groups of 3. You have 3 groups of 5, okay? So we want to make sure that they are understanding why they're doing what they're doing, and encourage them to use one of these representations or multiple of these representations to help them work through it. Because if you draw one of these and then it doesn't match the story problem, you can say, okay, I wasn't thinking correctly. Let me think through another strategy, or let me try again. If you're just solving it all in your head, that leaves you in a place where you can't figure it out from there, or you're just guessing. Okay? So, thank you for watching.